Today we're going to continue talking about work and energy doing work on other things. I got my cameraman Ben right there in the back. We're going to do a few experiments, but one of them has to do with this right here. It looks like just a piece of PVC because it is just a piece of PVC. You can see pretty much all the way down there. There's nothing on the inside, just this tube right here. And the tube leads to a pump, much like what we used for that bell jar, where we sucked all the air out of the jar and the balloon's head got bigger. All right, this is called a vacuum cannon, and we're gonna play with it.
Yep.
Now, Ben, we are going to be using a ping pong ball like this one. Oh, let me turn it this way. Penn, the king of ping pong balls, I suppose. And we're going to see what kind of damage we can get our cannon to do with just a ping pong ball. Now, if you've ever been hit by one, you may notice they don't hurt. What I've done is I've taken a piece of Mylar and duct taped it tightly on there. Ben, hold up the Mylar, show them what that looks like. Just a really, really thin piece of foil. That's pretty much it. Our weapon of choice is going to be the ping pong ball, which fits pretty securely in there. Actually, it's a little, I wonder if it's a little too tight. Can you go turn on the pump, Ben? Now, as he turns the pump on, it's going to suck air out of the pipe. Go ahead. Okay, turn it off. Now you can see that ping pong ball went straight back there real fast, didn't it? Can't even see it in the distance. Too dark. But it is loaded in there, and nothing else is going to be loaded in. Matter of fact, we're going to be taking things out. We're going to suck all the air out after we seal up the other side. Here is the idea. We're going to suck air out. No air will be left inside this whole length of PVC. It'll be a huge low pressure region. We talked about pressure. Pressure likes to push from high to low. That means the entire room here is the high pressure area, and the low pressure area is right inside there. Now, the ping pong ball is right here right now. Okay? We suck all the air out. We're probably going to see this suck in quite a bit and make a nice tight seal. Once it's loaded, I am going to take that knife, you can grab the knife, bud, and I'm going to pop a hole right here. All the high pressure in the room is going to rush inside the cannon to where there's low pressure. As it does, it's going to push the ping pong ball. Now, you may remember, ping pong balls, they're pretty lightweight. They don't travel too fast. You can get hit by one, and it won't hurt you at all. That's because air slows down the ping pong ball. But you know what? There's not going to be any air in front of this ping pong ball. So when the seal is popped here, all the air is going to rush in, hit the ping pong ball, and force it forward, all the way down the pipe, where we should see it do something to this soda can. That is the idea. It should acquire energy. What kind of energy? The energy of motion, kinetic energy. And it should do work on that can. We shall see. Now, as you can see, it's pumping down. We got a nice tight seal there. All right, stop the pump. All right. It's tight on both sides. You hear a bit of a hiss. Let's see. I don't know if we're losing any pressure. We'll run a little bit more. You recording? There we go. Stop. There we go. Okay, Benjamin, can you describe what happened?
So I heard a big bang, and then the can went flying over there, and the ping pong ball went there near the Jupiter, and flew back.
Yes, it did, and I got it. It's actually in pretty good shape. I think that's because Penn is a really good ping pong ball maker, I guess. Wow, I think it's too close. All right, so that was a little bit of destruction. Sent the can flying, I'd say about 15 feet. Let's see what we got. As you can see, the duck's pretty good shape. Show us the ping pong ball, Ben. Looks like it left some of the duck's paint behind here. You want to point that? There we go. Whoa. All right, a lot of damage done to the ping pong ball. It got ripped in half. The duck's okay, but it went flying. Seen what it does to a can. We've seen what it does to a duck and some paper. What will it do to a piece of wood? We're about to find out. Ben, was that an impressive level of destruction?
Absolutely.
Kind of unexpected?
Definitely.
Didn't think the wood would blow apart?
Nope.
That's what happens when a ping pong ball moves at 300 miles per hour, because that's about how fast it came out of that can. That was fun.